Hi everybody, welcome back to chemistry. Today we're going to talk about chapter 1, which is all about an introduction to chemistry. So like, what is chemistry? Why do we study it? Why might we find it interesting, hopefully? And how is it carried out using the scientific method? So if you don't have anything to take notes with in front of you, go ahead and pause the video and grab that. As I go along, I'm going to try to just keep moving along. If you need to pause at any moment, please go ahead and pause. Likewise, if I talk too slow for you, go ahead and increase the speed on the video. All right, let's jump in. So at the start of the chapter, we see some forensic scientists working in labs to analyze body fluids and tissue samples that have been collected at crime scenes. That's just one application of chemistry in our lives, but chemistry is all over the place, and I hope by the end of this video you'll be convinced of that. So the learning goal today is just to define chemistry and identify chemicals a little bit. So, chemistry, the study of the composition, structure, properties, and reactions of matter. Over here on the right, you can see an antacid tablet being dissolved in water. And if you'll notice, there's little bubbles that are forming. Bubbles are actually one of the visual cues that chemists use to determine if a chemical reaction might be happening. So we'll talk about that more in lab. There's a bunch of different visual cues as well as different smells and sounds and stuff like that that can indicate that a chemical reaction is actually happening. There's also some other examples of chemical reactions I have in your daily life. So whenever we cook food, that's a chemical reaction happening. Another one is like when you start your car. That is a combustion reaction, right? We'll talk about what that is later, but I'm sure you might have heard the term combustion before. That's a chemical reaction. Something like jewelry. I think that's how you spell it. If I'm wrong, I'm so sorry. Normally you can correct me in person, but I'm not the best speller and we're online now, so sorry about that. But jewelry tarnishing is another chemical reaction, right? Or even an old car rusting. That's a chemical reaction as well. So just like starting to see chemistry all around you and thinking about it more broadly than just like some Einstein person in a lab carrying out experiments. So chemistry and matter. Matter is another word for all substances that make up our world. Another way you could think of this is, or another definition I've heard is, anything that has mass and takes up space. And we'll talk a bit more about mass, but you can kind of think of it right now as measuring the amount of matter in a substance. And taking up space is kind of like the volume, right? How much space is that thing taking up? So anything that takes up space and has mass is matter. So you'll find that all of these examples are matter. The chair you're sitting on is matter. The screen you're watching this on is matter. You are matter. And then chemicals are another thing that sometimes we have a pretty narrow definition of what we think a chemical is, but actually chemicals are all around as well. So chemicals are substances that have the same composition and properties wherever they're found. So we think of things like, bad chemicals. Sometimes we think chemicals are not good, right? And some of them aren't. Some of them are very bad for you. But something like water is a chemical, right? Anytime you see H2O, you know it's water, right? And vice versa. If you have water, you have H2O. You might also be familiar with something like NaCl. That's table salt. That's just regular salt that you put on your food and makes your food taste really good. Or maybe bad if you put too much. But that's another chemical, and we eat it all the time. So some chemicals are bad and some are good, and I think it's important to move away from this idea that chemicals always equals bad. Doesn't always, right? You use chemicals in all the things that you have in your household as well. Toothpaste, shampoo. Calcium carbonate's a really cool chemical. It's found in your tooth enamel and eggshells, coral reefs. It's what makes your tooth enamel so hard and white. So just kind of an interesting thing. They do put it in toothpaste to be abrasive, and that's because of how hard it is. So just kind of an interesting tidbit there. For these learning checks in the future and today, I'd like you to try to pause the video and answer these yourself. So go ahead and pause, read through it, answer. You can answer more than one of these can be containing chemicals. So the solution is all of them contain chemicals except for sunlight. Sunlight is actually a form of energy. So, but the rest of them do contain chemicals. And I urge you, like, as you're kind of thinking about chemistry more now, try to look at the labels on some of your food or products and just think about, like, oh, what's that chemical? And maybe even Google it if you want to get real nerdy. I do that all the time. And normally in-person classes, I bring in some breakfast cereal. Can never say that word right. Breakfast cereal or some other thing to, like, read the ingredients of. So just starts to get kind of interesting. All right, moving on to 1.2, the scientific method. So thinking like a scientist, we want to start trying to describe the activities that are part of the scientific method. I call this like doing science. We talk about thinking about science, and we talk about science as a field of study, but what about when we actually carry it out, when we actually do it? Linus Pauling is this man here. He won the Nobel Prize in chemistry for the work that he did on chemical bonds, understanding chemical bonds and the nature of them. Interesting guy. Google him if you are curious. So the scientific method. This is a wordy slide, so we're just going to kind of break it down a little bit more. Make it a little bit easier to understand with an example. So this is an example of when you would use the scientific method in real life. So suppose you visit a friend in her home, and soon after you arrive, you start to sneeze. You're observing that your friend has a new cat. You're also observing that you're sneezing. I mean, that's an observation too, right? So you're making these observations about things that you're experiencing, about the natural world around you. And that's really the first step in the scientific method. The next step is forming a hypothesis from those observations. So you start to ask yourself, wait, why am I sneezing? And then you're like, well, my friend has a new cat, so maybe I'm allergic to cats. And so now you've formed a hypothesis about that observation that says, hey, I think I might be allergic to cats. Or I'm sneezing because I'm allergic to cats. So you've now formed a hypothesis. So this is step 1 here, observing. And step 2 is your hypothesis. The next step is performing experiments to test your hypothesis. And this is, what we do in lab all the time, right? We perform experiments to see if, hey, am I correct in my hypothesis, or do I need to revisit that? So in this case, we're testing our hypothesis by visiting other friends who have cats. That's step 3. We're doing our experiments so we have some data. Step 4 is our conclusion. Now, if you sneeze after leaving the other homes with cats, you you must come to the conclusion that your hypothesis is correct, right? I've been to all these other houses and I'm still sneezing. I think my hypothesis is probably correct based on the data that I collected from my experiments, right? So you could also determine that or come to the conclusion that you aren't allergic to cats and your hypothesis was not correct. So say you went to all those friends' homes with cats and you weren't sneezing. That's a good indicator that you're not allergic to cats. And that's still really valuable information. Even if your hypothesis was not correct and you proved it wrong, now you have more information about, hey, I'm not allergic to cats. So let me go back and reform a hypothesis about why I might be sneezing. If it's not that I'm allergic to cats, it must be something else, right? So this can be a cyclical, step-by-step process. So going back up here, the scientific method, the first step is always you're making observations about nature and asking some questions about what you see. If you have an observation that always seems to be true, we can state that as a law, and those are more of like on a universal level. So think of like the law of gravity. That would be a good example. And that just states like, a good example from your textbook is if I drop my chemistry textbook, it's going to fall to the floor, as long as nothing else is there to interrupt it. So that's a law of gravity. It's something that you can predict. That book is going to fall to the floor over and over and over again every time you do it. It's an observation. Hey, when I drop this book, it falls to the floor. So that's when observations are laws. And then you form a hypothesis to give a possible explanation to what you're observing, or a law, right? Why is the law of gravity always true? Why is that happening? Why am I always sneezing when I'm around cats? Then you perform your experiments to test your hypothesis, and you make a conclusion to figure out, based on your data, hey, is my hypothesis correct or not? And then you can reevaluate as you need to. So here's just another picture of that scientific method. I would urge you to kind of go through this on your own and make sure that you really understand it. And you'll see here that the law portion is kind of next to the observations, and that's because it's like a side category of observations. Okay, so I want you to do this learning check on your own. I'm not going to read through it, but we will go over the answers together. So check your learning. Did you do it? Okay. All right, so the solution. So during your visit to the gym, your trainer records that you ran for 25 minutes on the treadmill. That's an observation. He's just observing, he, she, they, is just observing that you ran on the treadmill for 25 minutes. It's just something that is being noticed. B, scientific studies show that exercising lowers blood pressure. Now, anytime you read a scientific study, you want to maybe double check and make sure that it's sound, that it was conducted well, that it's good science, that their process was really good, that they followed all the steps of the scientific method. Right? They made their observations, they tested, or they formed a hypothesis, they tested with experiments, and they came to a conclusion. And ideally, they would have lots of data, right? Oops, lots of data would be better than less data, right? So in this case, they have already come to a conclusion because they've gone through all of this process. If they did this correctly, right? If it's a sound article, and we're going to assume that the study was. So that's a conclusion. So scientific studies show. That's a good indicator that it's a conclusion. Your doctor thinks that your weight loss is due to increased exercise. The key word here is thinks, right? So this is not as confident as saying like, hey, this is what the research shows, which would be a conclusion. It's actually saying, I'm seeing that you've lost weight right? I've made that observation. So let's put an O there for observation. And that you've increased your exercise. That must be something that you're telling your doctor, right? And then your doctor is saying, hey, you know, I think that your increased exercise is why you're losing weight. And then the next step would be to experiment. The doctor hasn't gotten to that step yet. They've only gotten through the first two. The first two. So the next step would be experiment. And I urge you, I'm going to pause in a second, but I urge you to think about what kind of experiment could the doctor suggest to start running to figure out if the weight loss is due to increased exercise. I'm not going to tell you the answer to that. Just mull it over and think about it. This is the end of this video for now. The next video I'll probably have up by the time you see this, hopefully, or I might have you watch a video that has already been created. All right, so have a good rest of your day. I'm really excited to keep working on chemistry with you guys. All right, bye-bye.